So let's use these as an example. You're not going to have to derive them, but it's good to know. So e to the x times cosine x. So we'll need to use the product rule. So we're going to take the first factor times the derivative of the second factor plus the derivative of the first factor times the second factor. And I simply get e to the x times the quantity cosine x minus sine x. Here's another example. This time I'm going to use the quotient rule. So the derivative of the numerator is cosine theta times the denominator minus the derivative of the denominator, which is minus sine theta, times the numerator, which is sine theta, all over the denominator squared. And multiply things out so that I get sine squared theta plus cosine squared theta plus cosine theta. And remember that identity, that this Pythagorean identity, these last two terms sum to 1. And I can cancel 1 plus cosine theta, and I'm left with 1 over 1 plus cosine theta. Here's another example, a little bit more complicated. You need to use the quotient rule. So we want the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all over the denominator squared. So we need to use the product rule for this expression. So the derivative of the first factor is just 1 times the second factor is sine t plus the derivative of the second factor, which is cosine t, times t. And then this is not changed. So we simplify this to get sine t plus t squared cosine t plus t cosine t over 1 plus t squared. So to derive the derivatives of tangent and cotangent, we express them in terms of sine and cosine, and then use the quotient rule. Derivative of sine over cosine, so I would take the derivative of the numerator, which is cosine x, times the denominator, which is cosine x, minus the numerator times the derivative of the denominator, all over the denominator squared. So remembering the Pythagorean identity, the numerator just turns into 1. So that's 1 over cosine squared x, which is secant squared x. And then a similar computation for cotangent x, except there should be a negative sign here, by the way. See how there's a negative? It should have been carried here. So the derivative of cotangent x is minus cosecant squared x. So notice that cosine, the derivative of cosine was negative sine x, and the derivative of cotangent is negative cosecant squared x. And then finally the derivative of secant and cosecant. We remember how those are defined in terms of cosine and sine. And again, use the quotient rule. And since that numerator is a constant, when we take the derivative of the numerator in the first term, in the derivative, it's just going to be 0. So it simplifies a little bit, and get the sine of x over cosine squared x. And if you factor out a cosine x factor from the denominator, you get tangent x times secant x. And it's very similar to get the derivative of the cosecant, and again that would be negative. So there's a summary of all the trig functions and their derivatives, and notice that the co-functions are all negative.